All right, well, welcome to tutorial 3 here, where we are continuing on with some procedural generation. In this tutorial, we will generate a parametric asset. So an asset defined with some parameters, and then closer to the end, we will be introducing some stochastic generation by setting those parameters with random values. Of course, random values falling within an expected range, so that at the click of a single button, we can get a different asset or a slightly different design, right? And kind of speed up the asset design process by really quickly giving us some different designs to work with. So we're going to be generating a small little building, like a little house, with this tool. And so to get started here, well, the first thing we're going to do actually is create a little user interface so that we can get some input values from the user and use that to generate the asset. All right, so I have a new Maya scene file opened up here, and I have my script editor open on the side. I have already saved this script, so you definitely want to go ahead and do that. And I have also imported my Maya command set as CMDS. All right, so let's get right into it. So as I said, the first thing we're going to do here is create a little user interface. So let's put a little comment in there just saying what we're doing. And let's make that UI. So we are going to be storing the title of this user interface or this window. We'll just store the name of that window inside a variable. As with many of these API calls that we're using in Maya, the API call itself is just going to return the name of whatever node it just created. So in this case, we're going to write out here. We're going to use the cmds.window function to generate a window, and this function is going to return the name of the window that it generated. All right, so we'll pass in a few arguments here, such as a title. So the title of this window will be house generator, and we'll make the width of the window 400 pixels. That should work well for us. All right, so we've got that. Now, before we can actually see anything with this UI, we're going to need a layout, and then we're going to need some contents, some UI elements inside of that window. So let's make a layout here. We're going to use a column layout. Column layout. There are other layouts available to us, so you can search for those online to see what Maya has to offer. We're going to set some row spacing here, just so that we have our UI elements spaced out a little bit. So we'll do 10 pixels of row spacing. And then just to get started, we'll add a text element to this user interface. And the text element, well, we'll set that text content just by specifying the label argument here. So label. Well, we'll just set this to house generator as well. All right, so this is enough in order to actually see the window being generated. So with that ready to go, all we have to do now is just show the window with another API call here. So cmds.show window, and well, which window are we going to show? It is the one. Where we've stored the name inside of UI here, right? So if we just pass in UI as the variable UI as the argument here to show window, then Maya will know precisely what we are which window we're trying to show. All right, so here it is. It doesn't have a lot of contents in it. We can just see the window title and this little text element that we created. But of course, we have a whole lot more work to do here. Before we do anything else, we will just do a little quality of life improvement, and that is to first check if the window currently exists, that is when we run this script, right? We're first going to check if the window exists. And if it already exists, we're going to just delete it so that we can create a new one. And that way we won't end up with a whole bunch of copies of the same window. So we're first going to check if the string UI is in globals. Okay, so we are actually checking our list of global variables to see if this UI variable is defined. And if it is, then we'll also check if cmds.window. So this is a query command here. We're using the window function again, but in this case, it's kind of a query. It's not used to create a window. It's used to check if a window exists. So we're checking if UI exists, and then we're using the exists argument to, to turn it into a query, right? Where we're checking if this window exists, right? So we're nesting this if statement in the previous one, and if that window does exist, then we're going to do a delete UI, right? So delete UI, we're going to delete the window specified by this variable, and we just have to confirm that it is a window. Okay, so if everything is working properly, then even if this window is currently exists and is displayed on the screen, then every time, right, I'll just move the window to the side, and every time we run the script, it is actually going to delete whatever existing copy of that window that we have and allow us to just cleanly make a new one. So that is a nice little quality of life improvement whenever you're working with a user interface in Maya. Okay, so let's add some more user interface elements so that we can get some information from the user. So we'll start with some sliders. These are going to be integer sliders, so just setting integer values here. We'll use cmds.int slider grp for int slider group, and we're going to need to pass a couple arguments into this. So the first one is going to be basically the identifier that we use to identify this particular slider. So this one is going to be for the width of our little building asset or our little house. Okay, so this is going to be the width. The label, which is the text displayed in the UI, we'll just call this width. That makes sense. Its minimum value will be 1, and let's set the maximum value to 5. Just put those integer values in there. All right, so just in case you're curious, this is what we are creating here. Note the discrete jumps in position for this slider, right? We are only selecting integer values. And let's just copy and paste this and change it up a little bit to get a height slider. Same values, that works just fine. And a depth. All right, so height and depth. All right, so that gives us 3 nice sliders to work with. In addition to this, we will use some checkboxes. All right, so we're just trying to get some experience working with different UI elements here. There are others that you can search around for and use inside your applications, but we'll use a checkbox alongside these sliders. So we'll do cmds.checkbox. Again, we're going to need an identifier here. This one is going to be for whether or not we include a chimney with our house design. So this will be called include chimney. And again, the label. Should always have a label so we know what it is. Include chimney. All right. And let's use a second checkbox as well. For determining whether or not we will include windows, right? So we'll have an option to include windows as well. All right, so there's two little checkboxes here. And finally, we are just going to need some buttons. So we'll use cmds.button to create a button. We'll use a label. This first one is just going to be for generating the standard parametric house, right? So generate house. This will use the values that we set with those sliders and just generate kind of the regular house. The other argument we always need to pass in with a button is the command. And the command is actually just the function that we're going to call when we click that button. So it's kind of a really intuitive way of working with sort of an event-driven system, right? Where the event is the user clicking on the button here. So let's do that. We're gonna write a function in just a second called generate house. So I'll just put that in there. Note that you do need to have that generate house function call written out as a string here. That is how this function expects to receive that information. So generate house. And we'll also have another button here, which we will use at the end of the tutorial for generating the random house. So generate random house. And again, we'll just change this function call to call generate random house. All right, sounds good. So everything's looking good now. We've got all these UI elements. And well, when we click on generate house, Maya simply tells us that the function generate house is not defined, which is correct. We have not created that function yet, as well as with random house. All right. Don't forget to save your file. Save your script regularly. You don't want to lose anything. All right, so with the UI work out of the way, let's make a couple new lines here and make a section for our functions. Now, an interesting thing about Python is that it basically interprets the whole script in one go right when you run it. So Maya will become aware of functions defined after they're called. So this is kind of the only situation where we're going to do that. We are referring to, for example, generate house and generate random house before defining the functions. But for the most part, I mean, really just out of habit, for the most part, I am going to stick to the more fundamental way of defining functions where we define dependencies before calling them or before relying on them, right? So just to be aware of that fact that you can define stuff, you can define functions in Python after requiring them. However, still, I mean, there's often little reason to do this. I don't know. I'm just going to keep all the user interface stuff up at the top of the screen and just put the functions down here for convenience. But yeah, just to be aware of that. All right, so let's define some functions here. So again, in Python, to create functions, you just start with the def keyword, and then you can just write out your the name of your function. So this we'll start with generate house here, and again, I'm going to review this a few times as we go here because I know Python might be a little bit new to some of you. You might not have much experience working with it. So to create a code block in Python, we actually start with a colon to say that we're starting a new code block, and then it's actually the tab, the tabbing of the following code that specifies what code is included in the code block and what is not. Okay, so your tabbing is going to be extremely important when working with Python. Okay, so colon, and then you just tab yourself over. One tab to put the following code inside the code block. Okay, so this is going to be the code for generate the parametric house. I'm going to shift tab. I'm going to go back to the root level of my script and define another function here. I'll just make some more space so that we can see what we're doing. And this second function, remember, we need a generate random house function as well. So this is going to be for generate random house. Again, put my colon in there and just put a little comment saying, so this is going to be for generating the random house. All right. So that's good. Now, here's how we're going to structure this program. And I would encourage you, yeah, like, you know, as you're going through these assignments, you know, I'm starting to take on assignment 1 and for whatever other Maya, Python stuff we do in this course, you know, definitely the term project as well. That's going to be a big one, right? That's going to require a bunch of planning. Yeah, I would encourage you to start at the beginning of the process and really plan out how you're going to do things, how you're going to break stuff out into individual functions, because yeah, some of these problems that we're going to have to solve are fairly complex, and proper modularization is really the only way to wrap your head around it and stay on track. So yeah, hopefully this tutorial gives you a bit of a bit of insight into kind of how to think those sorts of processes through, and hopefully that helps you out as you take on some of the more difficult assignments in this course. Okay, so let's think about what needs to happen when calling these functions. Actually, let's just start with generate house, right? We'll deal with the random house right at the end. So what needs to happen, right? What needs to happen when we generate when we call this function? Well, we're generating the house. This is the parametric house, which means we need to have access to these parameters. So let's go ahead and do that. We are going to need to know the width of the house and its height and depth, right? So we are actually going to use the int slider group API call again, not to create a UI element, but to query a UI element. And so I'll show you how we do that. We just create a variable house width, and we say that is equal to cmds dot int slider group once again. And so we're going to specify which slider we are referring to. That is width. And in this case, it is going to be a query. So we'll set the argument query equal to true, and we need its value. So value equals true. Okay, so that looks good. Let's do the same for the height and the depth. And just so that we verify we've done this correctly, let's just print out those values. And again, here's another tip for working on like more complex problem solving stuff like this. Just print out all your values. There's really no excuse to not know what your program is doing. And a lot of times, if you just code away, create like 10, 20 lines of code, and you run it and you expect something to work and it doesn't work, and you can waste hours just trying to hunt down the issue. But if you just very carefully check your work as you go, just by printing stuff out, it can very often save you a lot of debug time, and is generally just a really good practice to get into. Okay, so that looks good there. I am going to run this, and I see that I have an error here. So let's just figure out what's going on here. And this is where Maya can get a little bit annoying, where it'll give you this error. In this case, it's an indentation issue. With one of my code blocks. Oh, actually, I think I know what it is. And it just gives you kind of this ambiguous error message, and you have no idea what it's talking about. So it might take a bit of getting used to just kind of thinking through what are the common things that might go wrong, and just dealing with those. So in fact, yeah, so what you're going to find is you're not going to be able to leave just empty function definitions like this in Python. Of course, the comment is ignored by the interpreter, and well, it thinks there's an indentation issue here because we've opened a code block and we're not really doing anything with it, right? So for the time being, I am going to keep the random house function definition just commented out there. Okay, so we are good to go now. So I'm just going to click on generate house. We're going to see we get 111 printed out here. That corresponds to the default values of 1, 1, and 1 for our sliders. We can just give those, just set some arbitrary values there, hit generate house again, and we can see those values being printed to the console. So we verified that our UI sliders and our query of those slider values are working properly. Always good to know. Again, as I said, I'd encourage you to get into the habit of just check your work as you go. So from here, now that we have these variables defined, we have grabbed those incoming parameters. Let's call another function, right? So again, let's think it through and think how we're going to use generating, how we're going to generate the parametric house and how that's going to be different from generating the random house. So again, as we know for stochastic generation, when it comes to kind of introducing a random element into the procedural generation process, really all we're doing is just randomizing parameters for the procedure that we're following, right? So whether we are parametrically whether we're generating the house using user selected values, or if we are randomly assigning those values, really what we're doing is performing parametric generation, right? So let's use actually the same function. Regardless of how these parameters are set, let's use the same function call here, right? So this is just going to be generate parametric house. And we're going to use the same function call down here when we do this for the random house. Okay, so that is all fine and good. Of course, when we click on generate house, now it's going to tell us, coming from line 36 here, well, of course, this function generate parametric house is not defined. So we need to do that. And again, just out of habit here, I'm going to define the dependency before I require it. Although, again, remember, in Python, it actually isn't necessary to do this. So generate parametric house. Oh, I've been writing too much JavaScript lately, and I put my curly brace in there. My apologies. All right, so generate parametric house. There it is. I'm going to put a comment in here. Generate house from incoming parameters. All right, so let's get to it. Let's start making some geometry here and start to model this house. All right, before we can do that, well, we need to specify those incoming parameters, right? We called the function. Actually, we didn't even pass anything into it, right? So let's take care of this. Let's get some parameters into this function definition and then actually call the function properly. So generate parametric house, we are going to be dealing with our house width, house height, and house depth. And, well, out of convenience here, I have just used the same variable names that we were using in generate house so that, well, we can just copy and paste that bit of code there. Again, let's just test and make sure everything is working. let's just print out those values. So again, click on generate house. First, it calls this function. It queries all these values, passes them in to generate parametric house, and then we print out the incoming parameters from inside generate parametric house. Perfect. Everything is awesome. So let's make the base for the house, right? So the floor of the house, it's just going to be a cube, right? Nothing special here. In fact, most of the components of this house are just going to be cubes. So base is equal to cmds.polycube, right? Remember, that is the API call for creating a cube. And we can specify, right, width, height, and depth for the cube. So, well, hopefully it's fairly intuitive for how we're going to be using these incoming parameters. So the width will be equal to house width. Now the height, actually, if you think about it, right, what we're trying to do here is make a cube where, well, so its width is, specified by the incoming parameter. Depth is also set by the parameter, but its height, well, the height of the floor should only be a constant amount, right? It should be fairly thin. So we're actually going to leave the height as 0.1 units. And then we'll set the depth as well. Of course, that comes from house depth. All right, that looks good. Let's run this code and generate a 1x1 floor. All right, so there it is, 1x1. Let's test out our width and depth just to make sure this is working properly. So there is a 4x2. We could do whatever we want here, right? Do something a little bit different. All right, so we are accurately using the width and depth. And again, keep in mind, the height slider is not affecting this because we set our height to a constant value. All right, let's make some walls. Oh, I didn't put a comment in here. I should put a comment in for create base. Okay, so that was the base. Now we're on to the walls. All right, so we're going to need 4 walls. Let's create them one at a time. Wall A is going to be equal to cmds.polycube. And so we'll set the width equal to, okay, so again, if we think about it, a wall is going to be fairly thin. So on at least one of the axes, we'll treat width as our x-axis as a convention here, okay? The height, or the y dimension, well, this value is going to come from the house height, of course the z from the house depth. So again, we need to have a constant value in here. Well, we know width corresponds to the x-axis, so let's start with the the wall where the width is constant. So we'll put in 0.05 units for the width. Height will be equal to house height. And depth is fairly straightforward. That's just going to be the house depth again. All right, so there's our wall. It is currently in the middle of the floor, so we do need to change that. Let's do a cmds.move. And again, we know that after creating a new cube, it is still selected. Therefore, we can just go ahead and do a move. And we're going to move it house, or actually, let's visualize this first. All right, I want everyone to be able to visualize these sorts of transformations so that you can effectively work on your assignments. All right, so we know this is the wall that should be pushed or pulled along the x-axis, and well, how far, right? How far along the x-axis should we move it? Well, we know this is a 1x1 floor, right? So the width parameter of this house was 1, right? So if we moved it 1 unit along the x-axis, that would put it all the way over there, right? And that's obviously not right. You know, it put it about there. That's not right. So we want to move it half of the width, right? So that's how we get a bit of an intuition for how to do this transformation. So we don't have to just, you know, type in random numbers and just brute force it to work, right? So cmds.move, we're going to move house width divided by 2 on the x-axis. We also need to move it on the y-axis, right? If you recall the position, the original position of the wall, we also have to move it half of the, well, this would be the height, right? I mean, this wall is currently, its height equals the height of the house. However, it should be positioned up here, right? It shouldn't be floating in the middle of the ground. So we want to move this wall half of the height of the house in the y direction. So let's put that in here. House height divided by 2 and 0 on the z-axis. So let's go ahead and run that. And well, I was working with the wrong side of the x-axis there, but there we go. We have moved that wall to the appropriate position. And now you will notice that I am using the floating point value 2.0 in this case here, and that is simply to force Python to do floating point math for us. Otherwise, it would be doing integer division and giving us whole values, which might not be appropriate, right? So we do want to put the floating point value in there just to force floating point math. So that works for wall A. Let's quickly put in wall B. And well, this is just going to go to the opposite end of the x-axis. So we could just negate that division so that we put it on the negative side of the x-axis. Right, so that will go on the other side there. Looks good. And then we are going to need to do the same thing for the other two walls, for walls C and D. However, we just have to watch which axes we are transforming things along. So these walls, with these walls, the depth should be constant, right? As a convention, we're considering the depth to correspond to the z-axis. So I'll put my 0.05 constant width on the z-axis there. And so that means that the width, right, the kind of the x dimension is going to be, in this case, specified by the incoming parameter. So we'll just carefully copy or paste in those values there. Right, so we can test it to see what we have so far. And well, okay, at least these are kind of, their dimensions are correct, but they're definitely not positioned correctly. So we do need to take another look at this translation here. And we will see that we want to move it. We do not want to move it along the x-axis. However, we will be moving it, in this case, house depth divided by 2 along the z-axis. And again, along, it would just negate that division for the second one. So there it is. We've got a nice little house there. Let's just test everything, throw some different parameters in here to make sure this is working properly. You want to test out your height as well, just to make sure you got that calculation working correctly. But this all looks good. All right, so we have created 4 walls. Let's combine them into a single object. We haven't done this yet, right? So here's a new API call that will be pretty handy as we are procedurally modeling things. Let's first select all 4 walls. So let's do a cmds.select. Of course, we know that the names of each of these objects we've generated are stored in these variables. So let's just pop all of those into this list of arguments. All right, so that will select all of the walls, and then we are going to do a cmds.polyUnite. That is going to, it's essentially the same as your standard mesh combine. So generate house, and now we can see that this is one object, and of course the floor is separate. All right, this is going to be really handy once we move on to creating those windows. We're going to have to do some Booleans, and so we do want all the walls to be one object in order to make that process a bit easier. All right, so the next thing we are going to want to do here is create the roof. So let's take a quick look at how to do that. Let's add a new section in here. Create roof. Okay, so again, we're going to start with the cube. The width, again, this is kind of similar to the base object, right? The width is going to be equal to the house width. The height is going to be constant. And well, as I was prepping this tutorial, I found that a value of 0.35 worked pretty well. Of course, if you're creating something new, you're going to have to try out a few values just to test out what makes sense for your application. And the depth, well, that'll just be house depth as well. Again, this is very similar to the floor, like the base object there, right? We do need its width and depth to correspond to the width and depth of the house. All right, so with that cube, let's just scale it up a little bit. We want our roof to kind of, hang over the walls a little bit, kind of have a nice little eaves along the walls. So, well, we know it's still selected, so cmds.scale, and let's scale it up 1.2 in each axis. So there it is. Our cube is a little bit bigger now. And well, currently it is, the roof is currently on the floor. So let's just go ahead and move that 0 on the X. Well, also 0 on the Z. We know that. But on the Y-axis, we are going to need to move it on the Y-axis. And so it's going to be, well, approximately house height high, right? Of course, we know the height corresponds to the total height of the house. However, I found that it worked best to just add a little bit extra to this. So I'm just going to add a little offset in here and add 0.2 to that, to the house height. So it's sitting right on top of the walls here. And again, you can mess with those little offsets if you prefer, based on how you want to design the house. Okay, so actually let's bring this back and just take a look at what we're going to do next. So I want to do like a taper to the roof. So this is going to involve selecting the topmost face here. And then, well, the quickest way of achieving the shape that I want to achieve is to actually just do a bevel and use a fraction like something like this. That's the sort of shape that I want to create. So let's just undo a little bit actually. The piece of information we are going to need to know is what is the face ID for this top face. So we can see that it is face index 1. That is very useful. And trust me, when you're doing polygon manipulations using Python, you're going to need to do this all the time. You're going to need to select something in the 3D view on a test object of sorts and check what gets displayed in the console here. So we're going to do a cmds.select. We're going to be selecting a component of the roof object. And again, remember that the roof, like this roof variable here, it is a, well, actually I should demonstrate that again, just so that this is clear. So print roof. This is a list with two elements in it. The first corresponds to the name of the object, and the second one here is actually just the name of the input node that just created the cube. But this is the name of the transform node, which is, in other words, the name of the object itself. So it is a list with two elements. We want to select the first element in that list. So that's roof 0. Again, just for speed, we'll do a quick concatenation here and concatenate .f square bracket 1 to select the face index 1 of that object. And we can just test that again. Okay, so that has selected that topmost face. Okay, so with that selected, we're going to do our bevel, cmds.polybevel, and we'll specify the offset, and we'll have that equal to 0.3. So there it is. There is our nice little roof. And we can test this on different widths and heights and everything, and just make sure that it always works. Great. All right, next we need to make the chimney, or create a chimney if that little setting, if that checkbox is selected in the UI. So after creating the roof, we'll create the chimney down here. So what we need to do is first check if the checkbox is, if it is checked. So we'll create an if statement here, and we'll check. Again, we're going to use the cmds.checkbox as a query. So we're going to be querying include chimney, right? That's what we called it. Include chimney. We are going to be querying this, and so as a query, we are checking its value, and we are checking to see if the value is equal to true. And again, as I'm sure it's obvious here, in Python, your true and your false is capital T, capital F, as opposed to other languages. So make a code block here. Again, just put a colon in and tab yourself over. Well, Maya automatically tabs you over. Thank goodness. The only good thing about this text editor. And let's actually call a function here that is going to generate the chimney. Now, let's just think this through. We always want to keep track of the name of the object we are generating. So if we're using a function to generate the chimney, we are going to want to return the name of the resulting object out of that function. And we're going to store it at the scope of generate parametric house. So that means we're going to want to do something to the effect of chimney equals, and then I don't know, we're going to have some function called generate chimney, and it's going to kind of work like this. Except of course we want the variable chimney to be available at the scope of generate parametric host. So let's just declare it out here. And again, it might seem kind of weird to put the square brackets in here, but we know that Python does store, or Maya gives us object names as this node, as this array of node names. So that's why I'm initializing it as a list or array. So chimney equals just a blank list, and then chimney equals generate chimney. And we are going to, well, we're going to need our width, height, and depth information once again. So let's just pass all of that into this generate chimney function, right? And again, sorry, to avoid confusion here, again, I am referring to the incoming parameters of house width, house height, and house depth for generate parametric house. We're going to pass those into generate chimney. And, you know, in this case, how about, just to get some experience working with parameters a little bit differently, let's actually pass them in as a list. So I'm going to put the square brackets in here. And again, we don't have to do this, but just to get a sense of how to work with the data a little bit differently, let's actually pass it in as a list, you know, with elements, house width, house height, and house depth. So we've called that function. Now let's go up above generate parametric house and define it. So generate chimney, and generate chimney, right? Remember, we passed all the information in as a list. So it only really needs one parameter to store that list. Okay, this is going to be pretty simple. Just, again, creating a cube. So chimney equals cmds.poly cube. Its width will be equal to, and again, I figured out when I was prepping this that 0.2 units makes for good width and depth. And so that makes for a good width and depth value there. However, the height, we will want to keep that at a constant 1 unit. Okay, so again, if we generate house, let's go to wireframe. If we generate just the normal house, there's no chimney. Whoops. However, if we do include the chimney, there it is. It's we get this cube, again, created at origin. So let's move it, and let us move it. Let's see here. So we're just going to move it a little bit on the X and Z axes. I found that the width divided by 3 and correspondingly the depth divided by 3, that works out quite well for us. So now again, remember, we have brought in those values as a list called dimensions. So the width is going to be dimensions index 0, right? Let's just remember that little technicality here. So that's going to be divided by 3. Again, we'll get to the depth in a second. However, the height, right? So dimensions, if I could spell, dimensions index 1. In this case, we are actually just going to move it a little bit up on the y-axis. So I'm going to go dimensions 1. So the house height plus 0.2, that worked out well when I prepped this. And well, of course, I already said that for the z-axis, again, corresponding to the depth here, is going to be dimensions index 2 divided by 3. Let's just test that and make sure that the chimney is positioned nicely, looks good. Let's test it on some different house dimensions, make sure we haven't made some dumb assumption and that it actually is working. All right, so it looks good. Just a little chimney there poking up the top. Looks good. And again, let's not forget the way we planned to do this was to return the chimney, the name of this object. We're going to return that once we are done here. Chimney. I'm having difficulty spelling today. All right, so there's that. And that should be good to go for the chimney. All right. So the chimney's finished, and let's take care of the windows now. Now this is going to be a little bit more complicated just because we are going to have to iteratively do some Booleans, but we're up for the challenge, aren't we? So let's go back to generate parametric house here. And again, we are going to check if the Windows checkbox has been selected there. So we're going to query include Windows. We're going to see if that the value coming from that checkbox is true. And if it is, then we are going to go ahead and call another function, this time called generate windows. Now, you know what I forgot to do actually was I forgot to store the name of the wall object, right? Remember back when we did this polyunite to combine all 4 walls into one object? I forgot to store the name of that resulting object because we will need that to do this Boolean thing. So that is declared now at local scope for generate parametric house. So again, staying in line with this whole like do some stuff, either generate or modify an object and then return the name of that object. We are going to we're going to do some Boolean operations on the walls, and then we're going to return the name of that resulting wall object. So now bear with me, I'll explain this as we go. It might seem a little bit confusing, but we will get there. So I'm going to say wall set is equal to generate windows. And again, we're going to do the same thing here that we did with the chimney. We're going to pass in the house width, height, and depth as a list. That will be one argument. And then again, I know it's going to seem a little bit strange here, but I am also going to pass in this object itself. I'm going to pass the wall object in as a second argument. And this will become clear in just a few moments why exactly we're doing this. So there's that. We do need to create the generate windows function now. Let's go ahead and do that. So this is generate windows. It will have an incoming dimensions parameter. And remember, also the wall set, also that object is going to be coming in here. Okay. So now this next part is going to require a bit of explanation. Let's start actually by creating some objects which we will use to do a Boolean difference on the walls to make some cutouts, right? We want to cut out some wall shapes. So let me show exactly what we're doing here. So we've got some kind of a house shape. And we want to basically make a couple cubes, a couple small cubes. I want to make a couple small cubes like this. And with those cubes all together like this, we are going to do a Boolean difference to kind of cut out this window shape. That is what we were trying to achieve here. So let's think it through and figure out how to do this. So inside generate windows, we are also, we're first going to need those cube primitives in order to do the Boolean difference. So the first thing we'll do here actually is let's just generate window primitives. Let's do that. All right, so we've defined a new function here, or sorry, we've called a new function that we haven't defined yet. So let's go ahead now and define that. Now, the reason I'm breaking this out into its own function is because we're going to need to generate 4 sets of window primitives, and we do not want to copy and paste code like an amateur programmer. So we are going to use a function to do this operation for us, and then simply call the function 4 times, like a pro. So let's generate our window primitives here. So again, we're going to need 4 different cubes. Might seem kind of funny. I'm talking about not copy and pasting code, and here we are sort of copy and pasting code. However, to just pop in like our, these 4 different cubes positioned exactly as they are, the most efficient way of doing it is to just explicitly specify the locations we're going to move them to. It's not really something you can easily automate with iteration. Anyway, that said, we're going to make cube A cmds.polycube. Its width is going to be 0.1, as will its height and depth. And we're going to move this. Right, remember that shape, those 4 cubes that I made? Remember that kind of grid shape that we have to reproduce here? So we're going to move it. And again, I've tested this. So actually, let's start with 0.1 on the X and 0 and 0 on the Y and Z respectively. So let's include windows, go to wireframe. Okay, so there is our first cube. There is our first cube. The next one, cube B. Oops. Cube B. Again, its dimensions are going to be the same. We're just going to move it the opposite direction on the x-axis. All right, so that should make sense. We're starting to build it out here. And then for cubes C and D, we're going to move those. So again, it's going to be 0.1 on the X, negative 0.1, right, to put them on either side. But we're also going to move them 0.2 units in the Y direction. So there we go. We have that nice grid layout for those cubes. We're going to select all of them. Sorry, that is a cmds.select. I'm going to select A, B, C, and D. And again, we're going to do a polyunite. All right, so we've combined the cubes to one object, and now we can just do our final translation. So a cmds.move. We're going to move them 0 on the x-axis, 0.2 on the y-axis, and 0.5 on the z. And I'll show you what that translation actually accomplishes. All right, so what that does is it takes this collection of cubes from here, moves it a little bit on the y, and it moves it over so that it is so that the cubes are intersecting one wall. So this will make it nice and easy for us to do some iteration and just kind of perform the same action 4 times to get windows cut out of all 4 walls. All right, so now that we're done with that, we are going to return the name of this new object that we just created. So return window primitives. Okay, great. So with that out of the way, let's go back to generate windows here and start to think this through. Okay, so we are going to be doing a Boolean operation. And here is how the Boolean operation works. So, okay, I'll try and build this out so it we'll try and construct this in a logical order so we kind of understand what's happening here. Okay, let's see here. I'm looking at my notes and I've got to kind of reconstruct this in a way that makes sense. So the object that we have just created there, right? Those window primitives, of course, we created that using the generate window primitives function. So we're going to store the name of that new object in window object. The next thing we are going to do here is we are going to actually rotate that object, well, we don't need to rotate the first one, right? Because the first one is positioned appropriately. It is positioned right here. So we don't actually need to perform any rotation. However, we're going to see in a second that subsequent iterations of this process is going to have a rotation around origin, right? So, if we had our rotation going around origin here, we did a 90-degree rotation, right? We could actually get these little primitives positioned at one of the four walls. So that's kind of what we're aiming for here. But we're actually, so I'll just put a little placeholder in here and say rotate, but we're not going to rotate the first one because it's already in the correct position. Then what we're going to do is we are going to perform our Boolean operation. We will need to store the, let's start by just doing the Boolean operation. So it'll be a cmds.polycboolop, and it is going to involve the incoming wall set object. All right, remember that is the original walls with no windows. So it's going to involve wall set and window object. Again, index 0 because this is a list. And the first index contains, or the first element contains the name of the object. And operation is going to be equal to 2. I think 1 is union, 2 is difference, and 3 is intersect. So yeah, I think I have that in the right order. But yeah, operation 2 is our difference operation, which is that Boolean subtraction. Okay, so let's go ahead and run that. Let's go back to shaded here. And we can see that that has at least cut out one set of windows here. So now we need to introduce that rotation that I was talking about. And of course, create a loop and have this iterate 4 times. So let's start to build that out. So we're going to need to maintain a rotation value outside of the loop, right? So that stays, so that retains its value at every iteration of the loop. So we'll just define a rotation variable up here. Then we're going to create a for loop. This is going to seem a little bit weird for those of you coming from C++ or maybe JavaScript or something. But in Python, to make a definite loop, so I'm going to use the variable. I'm going to use the iterator I, just because, well, of course, that makes sense to us C++ people, right? So I'm going to say for I in range 4, basically this is how you create a definite loop in Python. We have to create an iterable set. So in this case, we just have a set of values of 0 through 3, essentially. And I is just going to take on each of those values as we iterate through the loop. So this is a very simple for loop. It just is going to look a little bit strange for those of you coming from a different language. So for I in range 4, we're going to start with, actually, let's just get rid of this and tab this code over. So this now goes inside the code block of the for loop. So we're going to start with our window object, which is going to be a new set of window primitives, right? This is the advantage of generating those window primitives inside their own function. We can just make a new set anytime we want. And then because of that return value, we can store the name of the newly created object. So there it is. There's our new set of window primitives. They are currently selected. So we're going to do a cmds.rotate and do that rotation I was talking about, right? So that rotation is going to be 0 on the x-axis. It is going to be this amount of rotation stored in the variable rotation around the y-axis, and 0 on the z-axis. And we're actually going to specify a fourth parameter here. Sorry, a fourth argument, I should say. And that is going to be the pivot, because by default, this rotation will occur around the object's pivot, right? The object center. However, we want to change the rotation to occur around origin. So we'll just pass in the 0, 0, 0 tuple here to the pivot argument. All right, so that will work just fine. Okay, so now we come to the Boolean operation. And here's where this might seem like a clever trick, but logically it makes perfect sense. Okay, so the Boolean operation only works because we can specify the two objects, right? So here's our first object, here's our second object, do the difference on those two things. But the problem is that the Boolean operation actually creates a new object, such that wall set will no longer refer to the original object. Sounds like a mess, right? So what we're actually going to do is we are going to create a new variable, and you'll see in a second how we're going to use this new variable. So we're going to say that our wall result so the resulting wall with the windows cut out of it, the wall result is originally set to the wall results value is originally set to the incoming wall object, right, with no windows. Every iteration of the loop, we are going to be operating on wall result. Again, might seem a little bit strange. However, again, polycbool, just like pretty much every other API call that works on polygons, it returns the name of the newly created object. So we are going to store the name of the newly created object in wall result. We're just going to overwrite it. We're just going to assign a new value, such that when we get to the next iteration of the for loop, we will be operating on the newly created wall, right? The wall with some windows cut into it, right? We got to do this 4 times to cut in 4 sets of windows. Okay, so this is the proper way of setting up an iterative Boolean operation using Python. Okay, and we've got to increment that rotation value, right? Otherwise, it's just going to stay at 0 every iteration. So we'll just increment that by 90 degrees every time we run the loop. And there you have it. I know that was a little bit complicated, but we got through it, and we have generated. We've done that Boolean 4 times and cut walls out of every wall of the house. The only other thing we need to do here is return the resulting wall object, right? Because remember when we're generating the windows down here in generate parametric house, we are expecting to get a value out of generate windows. So that we want to return a value to store in this variable. Interesting little challenge here. We're not going to do it in the tutorial because we're already pretty much at an hour here. But take a look at it, right? If you change the width maybe, right? So think about it. In terms of depth, the depth is still 1. So those window primitives are in the correct position. However, the width, or the depth actually for that matter, is not considered when positioning those wall primitives. So if you want to walk away from this tutorial with a good understanding of how to do this sort of thing, here is your challenge. Here is your challenge. How do we consider how would we get the windows to work for other width and depth dimensions? All right, so there is your challenge. I would encourage you to take a look at that issue and think through how to fix it. Okay, we're almost done here. So we have, we can generate a house with a chimney, without a chimney. We can do windows. We can do no windows, right? No windows. And we can do all these different width, height, and depth options. So we basically have the parametric generation working properly here. The only other thing we're going to do inside this function is to just group all the final objects so that they're easy to work with after they're generated. So now there's going to be a different number of objects created depending on if we have a chimney or if we do not have a chimney, right? So we're first going to query if the chimney was selected. And in that case, our final house will be equal to cmds.group. So this is the API call for grouping objects. And then in here, we just specify which objects we're grouping. So it's going to be, right, just think through the objects we've made, right? It's going to be the base. It's going to be the wall set. Where was that? Here we go. Right. So either after just grouping combining the walls, or after generating the windows, doesn't matter. The name of the object is still stored in the same variable. So wall set. The roof. The roof is another object. And right, so again, if the chimney was created, we also are going to include the chimney in there. Right, so this is for with the chimney. And let's just let's just open up. Oh yeah, this is where my outliner always disappears. It is really quite annoying when this happens. Anyway, suffice it to say that this final object is grouped. It is now grouped. So we can easily transform this object. I'm going to have to go back to my script editor and perspective here. Okay. Otherwise, if the chimney is not selected, so we'll just put an else condition in here. The final house is going to be equal to the grouped the grouped version of everything but the chimney, right? We don't want to try and group an object that isn't there. So this will now work if we do not have the chimney selected, or if we do have it selected, and we can move everything around as one group. And last but not least, again, you're going to notice back when I had my outliner open there, there was a bunch of empty groups which were created as a part of construction history. So cmds.delete ch equals true. So that's ch for construction history. We're just going to delete the construction history so that we get a clean final result. All right, so let's just generate something here. And again, I'll go to a layout here. Or how about this? I'll change my panel to the outliner. I'll see there, now my outliner shows up. It's so annoying that I think that is a bug that is still in Maya. I don't know why it's there. Bring this back to a script editor. There it is. That's what I was looking for. Okay. So let's just start over from a clean scene here. So again, I should demonstrate without clearing your construction history, you do get some leftover groups, just some empty transform nodes in there. This is garbage construction history that gets created as you model. But when we delete construction history, we get rid of all that garbage and we're left with one group just containing the relevant objects. If we were to create a different house that would be contained in its own group, we could make maybe yet another house, and that would be contained, kind of a funny looking house, but that would be contained in its own group. Okay, so we just like to keep things nice and clean. Please do this in your term project. Whatever you end up doing, just, organize the final result so it is nice and easy to work with, and delete your construction history because it's pointless to keep that around once you are finished modeling something. All right, fantastic. So that is all good to go now. The only other thing we need to do in this tutorial is to introduce some randomness into this, some stochastic generation. And here it is, because we have planned this project out so well, it's going to be super easy to set up some stochastic behavior here. Okay, so we're going to start with the generate random house function. We're going to start it in the same way. We need to define these three parameters. However, their values are not going to come from the UI. They are not user input. We are instead going to use random values. So in Python, we can easily get at some random values by importing the random module. So import random right up at the top there. And we are going to set each of these parameters using a random integer. So house width equals random. That's the module. So it's going to be random.randint. Or you can Google these methods if you are curious about what they do. But we are going to get ourselves a random number between 1 and 5 inclusive. And of course, our width, height, and depth all vary between 1 and 5, so we can just use the same value in there. They need to be different, or we want the option to have them different. Each parameter is set differently. And so, after setting those parameters stochastically, we are going to generate a parametric house, right? We're going to do the exact same thing, and we're going to pass in those three parameters. So, when we click on the generate random house button, we are just going to get a random design. However, the design is still going to work. We could include a chimney, right? Actually, that's a good point. I haven't introduced the chimney or the Windows setting into the stochastic generation. So there's your challenge for the random generation. right? Add the chimney and the windows. Have those randomly turn on and off when you hit the generate random house button. All right, so there you have it. Parametric procedural generation as well as stochastic procedural generation in Maya using the Python API. Again, sorry for a long tutorial here. That was a lot to get through, but you are armed with the fundamentals now. So, this is going to be your bread and butter for completing at least your first assignment, as well as what most are going to choose for the term project. All right, probably going to stick to something around procedural generation. All right, so thanks for sticking with me through this one, and good luck. We'll see you in the next video.